A hands-on guide shows how to fine-tune models that call external tools. It parses XYZ-Aquila-SFT multi-turn tool trajectories. It converts embedded tool schemas and renders ChatML. It applies assistant-only loss masking and LoRA on Qwen3-0.6B. The workflow finishes with evaluation and exported artifacts. The tutorial implements a supervised fine-tuning pipeline. It streams XYZ-Aquila-SFT and parses nested multi-turn trajectories. It extracts and canonicalizes embedded tool definitions. ChatML rendering is applied with assistant-only loss masking. LoRA adapters are attached to Qwen3-0.6B and fine-tuned. Training uses gradient accumulation, BF16 when available, checkpointing, clipping, and cosine LR scheduling. The workflow exports LoRA adapters, tokenizer snapshots, JSON-L trajectories, and a JSON corpus report. Key technical choices include a nesting-safe parser for JSON tool calls and reasoning blocks. Embedded tool schemas are reconstructed and verified. ChatML rendering ensures predictable token mapping and assistant-only loss masking. Qwen3-0.6B is adapted with LoRA. BF16 detection helps collab compatibility. Teacher-forced probes cut trajectories before assistant tool calls to compare prediction performance. The pipeline turns rows into structured trajectory objects with messages, tool schemas, questions, and answers. Embedded tool definitions are canonicalized and reserialized. ChatML maps roles to tokens so loss can be applied only to assistant tokens. LoRA attaches low-rank adapters to avoid full model updates. Training uses gradient accumulation, BF16 mixed precision, checkpointing, clipping, and cosine LR scheduling. The workflow targets correct tool calling while preserving conversational reasoning and system prompts. Exported adapters and JSON-L enable reproducible iteration without full checkpoints. LoRA on the 0.6B Qwen3 model lowers compute needs and enables collab-level experiments with BF16. Teacher-forced probes give a direct measure of tool call prediction improvement. PEFT and LoRA are common for efficient model adaptation. ChatML preserves role-marked conversational inputs. This tutorial provides an auditable path to convert embedded tool schemas and measure tool call accuracy with teacher-forced probes. That reduces ad hoc dataset engineering. Opportunities include testing longer sequence length policies and scaling to larger models or more tool types. You can train agentic models that combine reasoning with tool execution. Use exported JSON-L to benchmark tool frequencies before costly runs. Limitations include a limited number of streamed examples in the guide. Qwen3-0.6B is a 0.6 billion parameter model. Results may differ on larger models. Teacher-forced probes check tool call prediction, not downstream tool correctness. LoRA is efficient, but has capacity trade-offs for large distribution shifts. For practitioners, the code uses Hugging Face transformers, PyTorch, PEFT, and Accelerate. BF16 support and CUDA GPU detection are included for collab compatibility. Exports include LoRA adapter, tokenizer snapshot, structured JSON-L, and JSON corpus reports. Source and further reading are in the description. The guide is on MarkTech Post, published on 2026-8/15. It contains installation, parsing, ChatML utilities, LoRA scripts, and export routines. Check the link in the description for code and details.